My name is Alan Shyness. I'm a member of the Lyme Land Trust and a 10-year resident of Lyme. This is a telescope that I bought back in 1985, and it is still going strong. My first telescope was not this one, but it was one that I got when I was about 12 years old. And with that telescope, I saw the planet Saturn for the first time. The good news is that telescope got me very interested in astronomy. The bad news is my parents who bought it for me didn't know a lot about telescopes, and it really wasn't a good one to buy. I don't know where that telescope is today, but one of the things that Scott and I would be devoted to is anybody was going to make a purchase, we would be able to answer questions about that before you made that purchase. There are good scopes, and then there are things that look like scopes, but they're not good scopes. My next telescope came at about age 25. It wasn't this one. It was a smaller telescope. It was very nice. And then came this one here. I got this telescope and I was so excited, and I set it up in my living room and, with the lights on, broke it down. And then I did it in my living room with the lights off. So I knew the whole telescope the way somebody might know a piece of camera equipment if you do that, or might know the helm of their boat if you're a boater. And then I took it to an astronomy club, very proud, set it up. And somebody came up to me named Gary, and he said, "Have you seen M13 yet tonight?" And I didn't know what he was talking about. And that's what a club is really, really good for, because Gary took me under his wing and he showed me not just how to set up my telescope, but how to use it. And somewhere down the line, of course, I was showing other people how to use telescopes. And that's one of the things that we hope that we can accomplish with a club. Look through each other's scopes, learn about telescopes, learn about astrophotography, and share that information. If we know a bunch, share it. If we don't know a bunch, learn about it. My motivation being here in Lyme and part of the Land Trust is to convince people that in addition to all the beauty that we see in the preserves and on the trails, that there's also beauty straight up that we can take advantage of here in Lyme in the dark skies. Let me take a moment and introduce to you Scott, or better yet, ask Scott to introduce himself.
Hello, everybody, and thanks everyone for hanging out with us tonight for a little bit. My name's Scott Mallory. I'm been a resident here of Lyme for 3 years, lived in Connecticut, I think close to 15 now. And like Alan, my first experience with astronomy was in fact Saturn. I was very young, probably 10 or 11. I had a very inexpensive telescope, cardboard tube, little 3 inch or 2.5 inch mirror. And I knew just enough to figure out how to align it, and the lens was plastic and the eyepiece was plastic, and it was enough to see a little detail. And it got me excited. I've always loved science. I've always loved astronomy and things of that nature. As my life progressed forward, I would periodically get reinterested in it. I'd buy a scope from here, like Alan mentioned earlier, not some good scopes. So a poor scope doesn't give you a good experience, so you leave it alone for a while. But when I came out to Connecticut, I decided to reinvest and reinvigorate myself in astronomy. So I bought a nice pair of astronomical binoculars. That really helped and very powerful. You can see a lot of detail with just binoculars. They're big, they're heavy, but they work. And then when I moved here to Lyme, I decided to treat myself to the telescope you see on the screen now. You're actually looking at it from behind. That is a 12-inch Dobsonian telescope. It's large. It has what we call a giant bucket of light. It's the aperture. Like Alan's, it's a different style, but it does much the same thing, just does it differently. He has a very beautiful scope that's perfect for taking astrophotography. The scope I purchased is perfect for point and look, point and look. And it's all about what do you want to do with astronomy? What do you want to study? Planets? You want to look at nebula? You want to look at star clusters? It's wide open field. And we hope we find people like us who are like-minded and want to be a part of this. And we hope we can foster this, this type of club environment and share some knowledge and learn things from everybody. So that's it for now.
Thank you, Scott. That's wonderful. It is a beautiful telescope. So what do amateur astronomers, that's what we call ourselves, astronomy club people, what do they do? What is astronomy club all about? We're going to take a few minutes and do it as a photo tour and give you an idea of some of the things, some of the equipment that we might have, and some of the things that we might be able to see. So typically an observing session starts something like this, in the daylight, with the telescope starting to get set up, and a table of equipment and people like my friend Mike here, who doesn't know astronomy but wants to look through the telescope when it gets dark. This is another view of Scott's telescope in the daytime. So you see a difference. You see it's on this sort of swivel and box. Other telescopes are on tripods like this here. And Scott mentioned it, but this out to the left is a pair of astronomical binoculars. They have slightly different characteristics, just like different camera lenses have different characteristics. But they're basically binoculars and on a tripod so that you can look up at the sky. And in fact, we would tell you that a pair of binoculars is a great first telescope if you're not sure how to dive in. And if you have a telescope and don't have binoculars, binoculars don't make a bad second telescope either. There's things you can see with binoculars that you can't see with a telescope. Think of it as having waterfront property, whether it's yours or you go, you go on a vacation and you have a nice wraparound deck. And with your eyes, you can see certain things. And with a pair of binoculars on the deck, you can see other things that you can't see with your eyes, vice versa. So you get two different views. It's a lot like that. Then you get people who get set up for a night of astro photography, and that's what you see down here. There's a camera with an adapter to make the telescope itself the lens to the camera, and the picture taking takes place through the telescope. The other equipment is there to find the thing you want to take a picture of and track along, something along those lines anyhow. So as the sky darkens, everybody is ready to get busy looking, and this is very beautiful. And I could assure you that even where your eye is probably attracted to in this photo is a great place to point binoculars one night and really amaze yourself with the view. Let's take a little bit of a systematic march through the types of things that we can observe with our telescopes and binoculars. And let's start with the moon. The moon is obviously something that we can look at. Here's a beautiful full moon. Very often we hear about the kind of moon that is coming up, the full moon, the harvest moon, a blue moon. But in fact, from an observing point of view, the full moon is actually kind of bright and washed out for detail. And what I mean by that is shown by example from this photograph, because now, especially within a certain distance of this dark light divider line, we see a whole bunch of detail in the picture. And we can see it again here in this picture. A lot of detail. The other photo looked, the first photo of the full moon looked a lot like this edge here. But in fact, look at all of this exciting detail. I'm going to put these side by side to emphasize what I'm talking about. Each of these three circled areas are the same exact area on the moon, but compare from the left to the right, like here. We see the craters. You can even see a mountain inside of the crater. And look over here, you can barely tell that the craters are there. The only difference is the angle of the light. So what's happening is this line is moving as the moon becomes more and more full, and the prime area of observing changes. So the moon is something that we could look at throughout the course of the month. And there are people who get very interested in the moon and the details, perhaps sketching at the eyepiece is a pastime for certain people to see if they can capture the detail. So subject number one, the moon. Moving out in our solar system just a little bit, we have the planets. This is the planet Jupiter. Now in the telescope, pictures of the moon These are pictures that we took. Saturn picture that we took. But in the telescope, it would be quite a bit smaller, number one, so that you don't get disillusioned. On the other hand, this photograph, as far as photographs go, is okay. It's not great. It shows the amateur status of the person who took it, me. But in the telescope, as you're looking, there will be moments where it will just crisp up all of a sudden. There's a little bit of an effect from the atmosphere that makes it go in and out and in and out. And when you're observing, typically you're sitting there relaxing your eyeball and let it crisp up. But Jupiter is a prime target. And not only you see Jupiter, but you can see at least 4 of its moons on a regular basis. And you can tell which moon is which by consulting to a guide. Scott and I both spoke about the planet Saturn. Again, Saturn in the eyepiece, much smaller, but in terms of the crispness during a moment of good seeing, much crisper. Really good delineation. For example, this dark spot between the rings. And besides Saturn, the planet Mars, the red planet. Again, much smaller in a telescope. This photo happens to be one along with Saturn that I just showed you. And they're the only 2 pictures we lifted, but we lifted these from the internet. I didn't have a good one to present. I could have found a much better picture of Mars, but I wanted it again to be something like the typical view, and then you have moments of seeing where it crisps up. But there are these little dark patches, and these dark patches have names. And the planet Mars rotates every 25 hours. And so from the beginning to the end of an observing session, you could go back to Mars and you can, for yourself, discern that Mars has rotated. That's possible to see during the course of the night. And other planets can be seen as well with increasing degrees of difficulty. Uranus and Neptune, because they're so far away, they're very tiny disks. With a hint of color to them, but no surface detail. Venus is easy to observe, not so interesting to see, but easy to observe and to see its phases, just like the phase of the moon. And Mercury can be seen, but Mercury sits close to the sun, so Mercury is seen close to sunset or close to sunrise. So therefore, at those hours, first of all, and second of all, with a good view to the horizon because it's very close to the sun. So those are the planets, the solar system and the planets. Really good objects for viewing, lots of fun to see, very satisfying when it's a clear night. If we move further out and we just talk about the stars themselves, this is a star. What I'm talking about is in the middle of the picture. And I hope that you see 2 stars. But I assure you, if I pointed to this in the sky, we just looked up with our eyes, this is a star. If you took out your binoculars, this is a star. But in fact, it's a binary star system. Every telescope will turn it into 2 stars with that view. You could see the space between them, and hopefully you can even see they have different colors. And binary stars are a sort of hobby within the hobby unto themselves. They are marked on star charts, which again, we have some, plus we can learn how to use these star charts for those who are interested. And they're marked and they have increasing level of difficulty to see the separation between the stars, which is a little bit of an enthusiasm for people to see, how good their eye is and how clear of a night it is. Besides stars and double stars, we can also see clusters of stars. There's a lot of clusters marked on the star charts, many of them visible to the naked eye as something not quite a star, and you look through your binoculars or your telescope, you see the cluster. This one might be considered a little bit difficult to tell. Where's the cluster? Here's another example of a star cluster. It becomes a little bit more obvious. There's a star cluster here. And in a telescope, these are just dazzling. It's like looking at a diamond. And the picture doesn't do it justice because in a picture, the star tends to get bigger and bleed as it's brighter, more pixels getting hit in the camera. But in fact, with your eye. Every star is a point, just some are brighter than others. So this kind of cluster is called an open cluster. There's a lot of them to look at, and they're beautiful. They're fun to find, and they're fun to look at. And there's a whole nother class of clusters called globular clusters. Now, these globular clusters are actually numerous in quantity. They tend to be around the center of our Milky Way galaxy, is where they live. And inside these would be hundreds of thousands of individual stars. Regardless of what you're seeing in this picture or what you see naked eye, at the center, it gets just too thick to see individual stars, but hundreds of thousands of individual stars. And all of this that I just showed you, these are all things inside of our galaxy. So we have next to us our moon, and then our planets, and then out in our galaxy, the Milky Way, these types of things to see. So let's pull back for a minute and talk about a whole different kind of object to look at. This is the picture of Scott's telescope, and I've done the outline here of the constellation of Orion for those who recognize it. It's sort of side of the body and the chest down to the legs, the 3 stars of the belt, and this is considered the sword, Orion's sword. And in that sword is a next kind of object that is fun to look at, called nebula. And in a telescope, something like this. In that circle, in the middle of that circle, that blob, the Orion Nebula. In a telescope, it will look like this shape-wise, but you won't see the purple because there's not enough light hitting the eye when you look to see color. Only in photography can you pick up the color, but there's a whole bunch of stars there. And the reason why is because this nebula is actually a collection of hot gases forming brand new stars. There's many nebula of many types. This is a most famous nebula, very easy to see, but there's a whole bunch to see. Here's another example of a different kind of nebula. This one is called the Ring Nebula. It looks a little bit like a smoke ring. And this one is actually the death of a star. This is a supernova remnant, which is to say a star that exploded, and this is the gas cloud left behind. And in a very large telescope, you would see a very faint star in the middle, which is all that's left of that baby. And then we get, again, in the category of nebula, but the ones we just looked at, we looked at in a telescope. This is just an ordinary camera lens taking a picture of the sky, but there's a nebula right there that's actually challenging to see in telescopes. It's almost much more so something to photograph. It's called the North American Nebula, roughly the shape of North America. But those are diffuse nebula, a whole nother category of things that we look for. And then there are nebula, as they were called in the last century, early in the last century, until people realized what they were actually looking at in certain cases, whole other galaxies. This is not a stupendous Hubble picture. This is a modest my picture. But the Andromeda Galaxy, which is right there, which you can see naked eye and in binoculars and in small telescopes, actually is something like 3 times the size of a full moon. It's out there. And it is the first thing I'm showing you that's outside of our galaxy. That one is 3 million light years away, and there are a lot of galaxies that can also be seen. This one's the brightest and the closest, but there's many that can be seen. And then we could talk about special events. For example, this is a picture of a, not very deep, but a lunar eclipse, which is to say a full moon, which actually went into the shadow of the Earth that is cast out into space by the sun shining on us. So on the other side of the Earth, when I took this picture, people were at high noon enjoying a beach day. But our side of the Earth was dark and the moon was full, and the moon happened to go through our shadow. That's what a lunar eclipse is. And those are fun events. you know, you could watch it happen over the course of several hours and take pictures of it. There is the sun. Some people like to do things with the sun. Of course, that's not done at night. That's done during the day. But even more important, that is not done without proper equipment. There are specialized solar filters that block 99.99% of the light. If you don't do that, you ruin the telescope, you will ruin the camera. If you're looking through it, you ruin your eyes. Terrible idea. But the sun, with the right equipment, is a target. The black dot in the upper left is actually the planet Venus. Planet Venus took several hours and went right in between us and the sun, so it was visible coming across the track of the sun. I took these pictures in Minnesota. I only have one, but I took a whole series of pictures out in Minnesota. The other marks on the sun are actually sunspots, which you see all the time when you look at the sun through a filter. This Venus transit won't happen again for 200 years. It was used in the 1600s to use trigonometry and parallax and observations at different points on the Earth to compute the distance to the sun as 95 million miles, which we now know to be 93 million miles. But Mercury does the same thing. It transits, so that could be an observing event, a special event. There's, of course, solar eclipses. Now, the thing about a solar eclipse, the solar eclipses happen between 2 and 5 times a year, but they only happen in the same spot on Earth about once every 800 years. So typically a solar eclipse is a road trip. Like I told you, I went out to Missouri to take these pictures. You can see some solar flares. Those are not artifacts. That's actually flares from the surface of the sun. There's that capture of the diamond ring effect. And then from time to time in our solar system, we get visitors. And this probably hard to see, but right there, there's a blue smudge right there. And that's actually a comet. And whenever there's news of comets that are visible, those are also fun events to rally around and make observing nights to be able to see that special event. So let me pause there. And that's a little bit of a tour of some of the typical things that we might be looking at, typical types of objects on any given night. What do we actually envision? Well, we think just like the Land Trust right now, we have hikes, we have imagining Lyme, we have geology walks, we go understanding the beaver and its effect on the environment. We think an astronomy club would be a neat addition to the Land Trust activities. We don't have a whole bunch laid out as to how that should work, in part because we would like the input of people who, like you, who would be part of it. But we envision, obviously, membership, people who are regulars, let's say, not necessarily just in the town of Lyme, just like people use the trails from neighboring towns, that's fine. We hope that we have some leaders so that we can pay attention to things like upcoming events and setting agendas if we're going to have meetings to share information, that type of, keeping the website maybe posted with upcoming events. We'd like to have an observing calendar that people can count on. That observing will take place. Maybe it's the new moon Friday and Saturday or something like that. And an observing site where we can go do it. We have dark sky here in Lyme, and we have places where we have the right kind of protected field that wouldn't have headlights. I have one out in front of my property that can be an ideal starting point. Periodic club meetings. I don't know if people would think once a month, let's have a Zoom on a topic, or every other month, but periodic club meetings besides the observing, and hosted events. and the difference to me between a hosted event and an observing night is a hosted event might be something in particular every now and then to cast a wider net to the public or a part of the public. For example, the Scouts, or maybe the local schools would like to have a science night where they come out chaperoned and students get to look through telescopes, or perhaps they get to take pictures and get a digital image. And depending on the level of interest, then in the future, a permanent observing site, perhaps some land trust owned equipment instead of us putting together the stuff that we already have. And a permanent observatory is not too crazy. It's not like something enormous that you would see on top of Mauna Kea in Hawaii. A 8x8 or 10x10 structure properly built with a place for the telescope to sit stably, with a roof that can slide off, that's protected from critters and from any other passerby, is an observatory. So that's pretty much what we wanted to convey as a starting point to open it up to some questions. Scott, I don't know if you've seen some questions come through yet through the chat window, but yeah. we really like to pause here and make me stop blabbing to you and get a chance now to hear your comments and feedback and questions and see what you think of all this.
Yeah, we have one came through from Emily. Emily, I'm going to ask you to unmute and you can ask your question. It's right up your alley, Alan.
Hello, I'm actually with my fiance here, Matt.
We live on Brush Hill Road. We've got some good dark sky and plenty of tree cover. Yeah, so our question was, we're kind of brand new to this. We are interested in getting more into it. We bought a star tracker just because, we didn't want to break the budget. Emily does photography, so she has a DSLR camera. So we're wondering, hey, what are some easy things to point out other than the Orion Nebula, which we have successfully found and took a very washed out photo.
Yeah.
And B, we have this adjustable lens, 75 to 300, and it's just kind of hard to pinpoint stuff. We find ourselves spending most of our time trying to, point and shoot with some kind of time-elapsed camera and not really spending a lot of time with it.
Yeah.
Well, I'll tell you a couple of things, and those maybe just convince you to try and do a session with Scott present or with me present. Even if we haven't set up calendars yet, you just got to sort of be in your bonnet to do it next weekend or whatever. Just connect with us informally. But here's the deal. First of all, when you're doing astrophotography, it is dark. It is hard to see. It's hard to focus. It's hard to know that you're pointing where you intend to be pointing. Some of those things are unfortunately sort of, the price of admission. Just like fishing is called fishing, not catching. You don't always get fish. There are certain tricks though. If you're using a camera lens as opposed to a telescope lens, the good news is usually set out to infinity focus that you'll get a good picture. One way to test that is to do that one night. Quickly take the picture, take it inside where you could see and see if you got good pinpoint stars, or sometimes you have to go a little bit off of the infinity. And once you get that spot, maybe a lead pencil and you mark it, or a piece of tape, you know where it should be. You should be able to take pictures for about, there's a formula, 700 divided by your focal length in millimeters. And that tells you for how many seconds you can take the picture before the stars will start to blur, because I assume that you do not have a motor that's moving them out. And the problem is that your camera is sitting on the Earth and the Earth is moving and the star's not. And after about 700 divided by F, so a 70 millimeter lens, 10 seconds, you'll blur. So what you want to do is take lots of 8-second pictures of the same thing. And then there's software. Maybe these days, even Photoshop would do it, but there's software that will stack the photos. Scott knows a little bit about how some Android cameras would do that. But these days we all stack photos in the after. So you take 8 seconds and take 10, 20, 30, 40 of those, and then those photos get stacked on top of each other, and you get an amazing picture. So that's a whet your appetite answer to say that we can work with you and see what specifically you are encountering and what your circumstances might require. And I say, starting tonight forward, we're here. You have our email addresses from the notifications. We're here.
Yeah, and if I could add one thing, as for the targets, there's so much software online that can help you see what is visible. I'm getting the hang of some fairly highfalutin software, some pretty fancy professional stuff, but there's even easier stuff to use that says, what can I see tonight? And you put where you live, and it will say, here's what's visible. And then it gives you the coordinates, and it's a place to start. That's how I started, just getting rough ideas. So yeah, please reach out to us. We'll work with you guys, because it is a lot of fun, and it's very rewarding to like, hey, I did this. I took this picture. It's really neat. And you saw it with your naked eye. You took a picture. It looks fantastic. So yes, this is why we want to do this, to work with other people and share this knowledge.
I also just typed the name of a book, Field Guide to the Stars and Planets. It's available for sure, even used hardcover copies of this book. This book is amazing. It's so invaluable. There's software, and Scott's going to be the software technology guy, and I'm going to be the old school guy. You see the difference here? There's a lot less hair. Learning how to do it, looking at a book. But a book like that, you can figure out, what time of the year, and you go to that page, and it will show you, looking south or looking north, the major things that are there. And there's a little one-page description of the big ticket items. And with the camera, that will give you a very good idea where to see things. And what you'll see is it's referring to clusters and galaxies and globular clusters, just like I showed you pictures of. So that's a good one. And there's another one, which is Wiltirion. Anything Wiltirion Sky Atlas. Is also, I have one, it's enormous. They also come in little book form. Each one of these is a big chart that opens up. But again, Wiltirion is considered the master of creating star atlases, and that's in fact what is reproduced in the Peterson Field Guide to the Stars and Planets is Wiltirion charts reduced to hardcover book size. Okay, who else have we got here, Scott?
That's all we have.
That's
Anybody
not
else have
all
any
we
questions?
have. I'm going to unmute everybody and create a food fight.
We could do that. I have the buttons to unmute everybody.
Unmute everybody.
All right, let's do that. You can unmute yourself if you'd like to speak. You now have the ability to unmute.
Everybody unmute for openers.
More questions. Should we use a PC or Mac? And that doesn't make a difference with this technology.
Right.
Either or, it's written for everybody these days. And there's even tech just for your phone. I have a couple. I use one for my phone. I rather enjoy it because it tells me how good the weather is. What's it called? Make sure I get the right name. One of my favorite tools. It's called Night Sky or Night Sight. Is that right? Yeah. But there's so much out there, and we can send you some links. We'll put up a page of some FAQs about software that we use, books we might recommend. So again, we want to share this knowledge with everybody.
Do we have anybody who's on tonight who actually has some experience with just now? Emily talked about their attempts at astrophotography. Do we have anybody here who likewise has attempted astrophotography or just observing in general?
I didn't hear who that was.
I think that was background.
Is that William? Or was that background noise?
I think that was background.
Okay.
How about some feedback from somebody? I see a few people unmuted. I'm interested to see anybody who thinks that they would be interested in actually going out to observing sessions. Linda just wrote a question recommending a good introduction to sky maps. Again, I think that the Peterson Field Guide to the Stars and Planets, if you were to Google that, and perhaps on Amazon or elsewhere, a used copy is perfectly acceptable. It's not an expensive book. It's not a very high demand book for sure. That book is outstanding because it has little chapters that describe things a piece at the time. In the middle of the book has the actual star charts themselves. It has a section how to read those star charts and how to use them. It has orientation maps in it. I think you'd be very pleased to look through a book like that. I've had mine for 30 or 40 years. It's on the shelf forever. And I still look at it. This time of the year, I'll be on page so-and-so because that's what's out there. And I'll just remind myself, because I can't remember from last year, which types of things are now available to be seen. And I decide what my observing session will be about.
Anyone else?
You see the Survey Monkey link that is out there, and I'm gonna also send a follow-up email to put the link in there again. I encourage everybody to do that for us so that we can gauge the type of interest that you all have in this, and just respond accordingly as we set it up. Let me see. Yeah, Linda, sky charts being confusing. It's one of the things that I would do with us out at night in the field is help you understand what you're looking at, why things are rising in the east and setting in the west. And I don't mean to say anything oversimplified, but it until you understand that orientation, it can be very confusing. For example, that picture of Orion I showed you, and you had the lines going up to the shoulders and the belt in the middle, and then the lines going down to the feet. Beautiful. That picture, I can tell you, was taken facing south. And the reason it was taken facing south is because Orion was standing up. Because if that picture was taken facing east by the sunrise, Orion would have been laying down on his left side, and his feet would be, he would be sideways, and his belt would be pointing up and down. And then as the Earth rotates, it comes up, and then the Earth rotates some more, and he'd be laying down the other way before he set. And it's not that the stars are moving in that fashion. All it is that we're sitting on a round globe that's turning, and it's making everything move. And the up-down line that matters is from due south to the North Star behind you. If you're facing south, everything is actually sitting parallel, like sections on an orange. So when they rise, the sections on the orange are like this, and then the sections of the orange are just coming up until they're straight up and down, and then they're going the other way. And when you get that figured out and you look at a star chart, things start making a lot more sense. And again, out in the field and sort of proving that concept, more so with a telescope like mine, which is set up to move along the lines that are the section of the orange, or 90 degrees to it. That's how my telescope is set up. Scott's telescope is set up to say, that's the moon, I want to look at it, and you just point it at it and look at it. Two different telescopes with two different design concepts.
Yeah, and they answer different levels of interest for people who, want to really delve into the long views and soak up what they could see or do photography. And there's people like me who want to jump around the night, and we call that star hopping. And with star charts, when you learn how to use them, this is my star chart. This is what I recently, it doesn't show up. There it is. Oh, almost. It's the Rocket Sky Atlas, and it too has charts, and it explains everything, what I'm looking at. And then when you recognize two stars here, a bright one there, and a little fuzz over here, and then move my telescope a few degrees, and it's how you star hop. And it's really quite fun to do. And you finally guide yourself to a target that you want to look at. a double star, a blue star, and a red star that are in the same field of view. It's very exciting, and you see how clear the colors are when you have the right kind of equipment. So, and that's we can help you with all this, and we'll gladly get online, and we'll do an actual in-person session eventually, of course, another public viewing, and we could maybe start early and talk about this in daylight, what we're doing and how some of this works. And the orientation is a bit tough. The terminology, of course, my telescope is Alan's telescope's equatorial. I have an azimuth and alt telescope where I just zoom around this way and this way. And Alan's telescope works off an equatorial mount as it turns opposite to Earth, so it's going to the same point in the sky. It's kind of wild how that works.
Both you become accustomed to both of those types quite easily, and hands-on and seeing it in action makes it all make lots of sense. Another area that I think of that people have trouble with is understanding something like the phases of the moon. That's another thing that I think we could do, standing around in a circle and get a sense for what's really happening in 3 dimensions around the Earth. Or why can we see Orion in the winter but not in the summer? What's that all about? Why is that happening? Getting those types of things, just aha moments, because they're really not complicated. It's just that our perspective is based upon being on the Earth, where it feels like things are circling us. But in fact, all that's really happening is we're going around in a circle once a day, and the whole planet is going around the sun once a year. And those two things account for 99% of what is sometimes disorienting when we're looking at a map or a chart. Let me see. Other questions? If you think of a question, just type it in over the top of me or unmute yourself. I think we've allowed people to unmute themselves at this point, right?
Feel free to ask away. We have
anybody
another
can
10
unmute.
minutes.
So I showed you a picture of Saturn, and in the picture of Saturn, you saw the rings of Saturn. This doesn't happen very often so perfectly, but picture in your mind that Saturn is going around the sun. We go around the sun once a year. Saturn goes around the sun. I don't know the number. Maybe it's once every 30 years. I'm not sure, but absolutely, Saturn that's out there is moving in its orbit. And back in the late 80s, it was doing that and was going to go right in front of a very bright star in the constellation of Sagittarius. And it took it a couple of hours from when the ring first hit the star until the star disappeared behind the ring. And then for the next 2 hours, as Saturn kept moving ever so slowly, suddenly looking through your telescope, you got to feel that the stuff out there is 3-dimensional, because the star itself was blinking on and off as individual rocks in the rings of Saturn were blocking or not blocking, and then next rock, and then not blocking, and then next rock. So what from far away to us looks like a white band with one dark line in it, in fact, is millions and millions of boulders, and blinked on and off like that. It was just such a cool thing, because it proved to you firsthand that, hey, that's a planet out there and it's moving. It was so cool. And so that's called an occultation. More often, the moon will just barely graze at the top or the bottom a star, and people also enjoy doing that. And as it barely grazes, the mountains on the surface of the moon cause the starlight to blink on and off. So again, you get a sense of something that's happening out there that you can't really see just looking at the full moon. Those 2 things that come to my memory. Okay. Well, I think maybe no more questions. Lastly, Scott, help me. This is visible, the whole thing. It's not blocked out.
Yeah. Yep.
Well, the weather's not exactly cooperating tonight, but just a few nights ago was a new moon, which is to say wherever you look, there was no moon. And the reason there was no moon is because the moon was in between us and the sun. And so all we really had facing our planet was the dark side. And 2 nights ago, if you happened to look out, you probably saw something like this sliver of light close to the sunset. And here's something that maybe you could do yourself and get a feeling for what I call celestial mechanics, what's happening out there in space, these things moving. The first clear night you can, which probably is not until Saturday night. I think tomorrow night's probably still cloudy. But take a look right at sunset, find the moon. It will be up there someplace. Look at sunset, look up to the left, 45-degree angle or so, you'll see it. And just see what time it is. If you have a piece of paper, maybe try and draw a circle and, what was bright. And then do that 2 or 3 nights in a row at the same exact time. And what I want you to be looking for is the moon won't be in the same exact spot and the moon won't be lit up the same exact way. To the extent that you're not exactly sure what's causing that, observe it first, and the next time we talk, we could talk about what exactly is causing that. So I call that the Young Moon Challenge. True Young Moon Challenge. You go back 2 nights ago when the sliver was there. Again, there are people who love the challenge of finding the young moon as close to new moon as possible. So if it was like this, when this picture was taken, 6 hours earlier, maybe that sliver was half. And a few hours earlier, it might have been the tiniest, thinnest line. And that's what a true young moon challenge is like. It's a fun thing to try and do. Okay, so let's wrap it up. We all are not going out to observe tonight because of the weather, but we have things to do. I want to thank you all for your interest and for coming on tonight. And I hope that what we shared with you was interesting, and I hope that it made you interested in doing more of this live out in the fields with telescopes, because we'd love to host you like that. I'd like to thank Scott for all the work that he put into making tonight happen and for helping with the hosting duties and the Astro photographs. And also thank the Land Trust for supporting this idea. I hope that we all make it happen. To that extent, there is the survey. Please do it. It's 8 quick questions. They're all check boxes except asking to confirm your contact information if you really want to be part of this. And I really would love to have individuals who want to join up with Scott and I in planning the next event. If you have experience with astronomy to help us, I envision, for example, that we will have a page on the Land Trust website that we want to keep current. It might be a box that's just the plain vanilla, when's the new moon, when's the full moon, if a planet is available, that sort of thing, or maybe little topics of interest. So if you would do that for us, like I say, that's the link. It's in the chat window now, and I will also send it in the email. And with all that, I'll say goodnight to everybody, and thank you very much for joining.
Thank you, everybody. This is a lot of fun.
Thank you, guys. Appreciate it.
All righty. Have a great night.